But I am an electrician and I will either smoke it or fix it. There's no other thing. Yeah, red is black and plus is minus. It should work.
You know, when I look at something like that, I just see a bunch of things that almost looks like candy.
This is made out of granite. This is 600 millimeters from here to here.
Yeah.
Okay? This is not your 2x4 US wall where you can simply run a cable.
Yeah, usually when we do electrical stuff, we get the most desktop mechanic comments.
Those are desktop electricians then, okay? Yeah. Oh man, look what she got.
Look at that package. It's awesome.
So where did that come from?
Originally, that came out of Las Vegas, USA. It got mailed to my house, to me. It has my name on it.
Oh, that's already terrible, because whatever it is, I'm gonna have to ask then, can I use your this? Can I use your that? So this is gonna haunt me forever. Okay, so I'm gonna unbox Vera's package, okay? Am I permitted to do that?
Yes.
So this is from Arthur and Maria from Las Vegas, so it's really incredible. And this will be our first power tool set from
Milwaukee.
Milwaukee.
Oh,
look at that, Nevada.
License.
So there is a head for you. Okay. Motorcraft.
NASCAR.
Oh, there's a NASCAR head.
It's a NASCAR head. I'm going to wear that all the time now.
Looks like they got opened by customs. And holy cow, what is that?
These are clips.
Clips. Oh, wow. These are indeed all Land Rover OEM bolts. These are the interior clips.
Yeah. Oh, you lost some.
You can buy them, one of them for like 4 or 5 pounds, okay? They're like 100 pounds in here.
Oh my God.
And these are the interior screws, also all OEM. For a Land Rover guy, this is like gold, okay? You can weigh this up in gold. Yeah, these are the clips to cover the hitch.
Oh, now the one you made out of aluminum.
Yeah.
Oh, that's awesome.
And look at that, they are...
We love it.
We love it. And look at that,
it
doesn't... Oh, it says Toyota on it. So, Lexus.
Wait a second. The Toyota here. The Lexus here.
LR3 2007. Look there is another 100-pound bag of clips. This is incredible.
These are Japanese screwdrivers.
What do I have to do if I want to use them?
You're gonna have to ask for permission.
For the next 10 years.
Yeah.
Oh, look at that.
Actually, never seen anything like that. Oh my God, there's more Milwaukee stuff.
Our first Milwaukee power tool.
That will go on vacation with us.
This is incredible. Ooh, there's another one of the Japanese ones where I have to ask for permission.
For the rest of your life.
Incredible. Another battery.
That, oh my God.
Unfortunately, this is Vera's now. Magazine in. Ooh.
And it's much smaller than the Makita.
Oh, much smaller.
Yeah.
And look, the Makita has this little lever here in the back, which always gets caught up and then it latches in the other direction and it gets you stuck. Yeah. This is much smarter. Also Japanese. So I guess this is a Toyota hose removing tool, see?
We don't have a hose removing tool.
We got one which is not as nice as this one because this one is Toyota approved. It's out of Japan. Another screwdriver out of Japan. They are good for the palm of your hand. Instruction manuals. One more set of clips. These are the interior clips from the center dash where we lost one recently. So we're going to be able to replace all your clips. Look at that. And a bag.
Yes, I love the bag. So I have my very own toolbox for when I go on trips with my car.
Let's charge this up. What is that? So what do we do with that?
Well, we're gonna have to dig out our converters. Because remember guys, we lived in the US.
So this is rated 120 volt 60 hertz, okay? We got 230 here in Germany and this is the wrong plug. So most likely if I just put another quad on it, it's gonna smoke this thing because it doesn't have variable AC input rating. So we're gonna have to probably do some rewiring in here. But I am an electrician and I will either smoke it or fix it. There's no other thing. Yeah, red is black and plus is minus. It should work. So You know what? We should do that right away. Maybe make a video out of how to rewire these, and if the smoke comes out, you can't get it back in. So Arthur, don't be scared. A German electrician will figure this circuit out in a heartbeat and get the smoke out of it.
I love the license plate.
Okay, do I have permission to open up your power supply here?
Yes. And by the way, I'm in a tank top, but it's still February. I voted today. Yeah. And Christian did too, and Robin.
Entire Germany was supposed to vote today, okay? We had to vote to stop the deindustrialization of our country.
Yes.
Okay, even though it's probably too late.
Oh my God. Yes.
Okay, no politics on our channel.
No politics.
Okay, this might be an interesting project. When we moved back from the US in 2003, we had all kinds of equipment, which was of course from there. And because I'm an electrician, I still remember how I had to rewire most of those power supplies or collect new ones and so on. Most of the time when I open these up, I see immediately if this is a switching power supply or a transformer. And if they are switching like this, most of the time the manufacturer made them so that they can be wired up for 230. We're gonna have to analyze this little circuit here. I show you guys how to do that. There are a couple of simple tricks. If you know them, you can rewire any circuit.
You know, when I look at something like that, I just see a bunch of things that almost looks like candy.
Okay, let's make this a really boring video by analyzing an electrical circuit.
Oh, Christian, please take a picture before you erase everything.
I took a picture of this, okay?
We still want to know who screwed it up.
And by the way, if you want to clean a whiteboard, this is what you use. Okay, then it works really good. Well, maybe not.
So, okay, a microfleece and spiritus.
Switching power supplies have always one circuit in common. They have a rectifier bridge in here, which is made up out of diodes, okay? To convert AC to DC, and that is always the same. And we look for that circuit in here, which are these 4 diodes. You see them in here. Sometimes this is one integrated circuit with 4 pins, but in this case it's 4 individual diodes. And the way they look in the circuit is always the same. They point towards plus. So they like this and they like this. So out of the circuit, this is going to be the plus line and this is going to be the negative line. We see that immediately when we look at the circuit. And this here is usually the AC line connected here and here. And now we got to dive in and find out what's here before and what's here behind. And the way I do this is I mark on the back side the diodes here in the circuit so that I don't screw this up. Like right here, I see a diode right here and I mark this one here.
Whoa.
Oh.
I broke it.
Here, and there is one here. And there is one here. And then you can see this one has the minus here on top. So the diode looks like this. And I do that on all 4, and then I show you guys what the next step is.
Oh my God.
With the rectifier now identified, I can go to my input AC lines and figure out how they connect to this circuit. So I know I'm gonna have some AC coming in here, okay? And from that AC, and you can see it goes here to this brown thing, and that is a fuse. So we go here and we draw a fuse. It says 3.15 amps on it. And then the other AC line down here goes first to this thingy here, and that's called a varistor, okay? So that's a voltage dependent resistor, and it's connecting those 2 lines together. And I think the symbol looks something like this, okay? This is a 10N271K, N271K. And that's usually a critical element, because if we have only 120 volt here, I'm sure this thing is only rated for 120 volts. So we're going to take a look if this is true. I'm pretty sure the 27 actually means 270 volts, and that's not enough for a 220 volt circuit, because if you multiply 220 volts with the square root of 2, so 1.41, you get more than 270, okay? The electricians can follow me now. So this is actually connecting here. There is a bunch of stuff here in between, like these 2 little SMD resistors. I'm not gonna give a damn about these, because I'm pretty sure they're not changing this stuff. And then there's this green thingy here, which is an NTC, okay? That's the same type of varistor, and it's there for surge protection. This is an NTC. But because it's in series, I'm not going to care about that one either. And then this circuit goes to here. This is our incoming circuit, and we want to go now from 120 volt AC to 230 volt AC, okay? And when we look at these components, we're not going to care about the fuse. The fuse is going to be a little bit too large because the current is going to go down when we run it on higher voltage, okay? So if something goes wrong here, it's going to blow the circuit board because this fuse is going to deliver twice as much current before it blows. This thing is going to be the most critical one, so 10N271K, and the best way to find out if this thing is now rated properly is to ask ChatGPT.
Oh my God.
Is a 10N271K varistor suitable for 230 volt AC input circuits? 230 input circuits? Yes, we sent this. A 10N blah 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 has a nominal voltage rating of 270 volts, which means it starts clamping voltage surges around this value. When used in a 230 volt AC circuit, we need to check if this rating is appropriate. 230 volt AC RMS has a peak voltage of 325 volts. So 230 volts times the square root of 2. Huh? I still know my stuff, okay? I learned this like 35 years ago.
Beep.
A varistor should have a maximum continuous operating voltage higher than this peak value to avoid continuous leakage or premature failure. The maximum continuous voltage, 175 volt AC, is significantly lower, so this is coding to 175 volts AC apparently, is significantly lower than the 230 volt AC mains voltage. This means the varistor could degrade or even fail when continuously exposed to 230 volt AC, okay? Recommended alternative, I didn't even ask for that. A more suitable varistor would be something in the range of a 10D471K or a 14D471K, 471K, or a 14D471K. That's what we need. So what we're gonna have to do is replace this varistor with something like this.
And do we have something like that?
Well, we're gonna look for it in the dungeon.
Oh my God.
Now, before we go ahead and replace this, we're gonna have to analyze the secondary circuit. And that is made up for sure by these two electrolyte capacitors right here. And you see they have a polarity. That tells me they are in the secondary side. And I'm gonna have to figure out how they are mounted to the rectifier bridge. So I look for this point here, going over to them two, which is this one here. Then it goes here to the minus pole. So I'm down here on this one. And this goes to the minus pole, so it looks like this, and this is minus, and this is plus. And then from this plus pole, it connects over to here. There's like a little jumper behind it. So it goes like this, like that. They are in series. Okay, and then this is a minus, and this is a plus. What usually happens in these kind of circuits, if you got two capacitors in series like that, is that they charge one capacitor with the upper sine wave and the other capacitor with the lower sine wave. So when the polarity comes in plus, they charge this one. When the polarity comes in with the negative sine waves, they charge this one. And the way this is done is usually with a connection like this. This is a typical circuit where you use 120 volt to charge a DC voltage capacitor package here in the back. And then this voltage is basically 2 times 120 times square root of 2. Yeah, this gives us 340 volts. And when we convert this now, making sure that this varistor is not going to blow up, all we have to do is disconnect this line. And what that then does, 1 times 230 times square root of 2 equals, and it's going to be exactly or roughly the same voltage back here.
Yeah, but because 2 times 120 is 240.
Okay, so we're going to have to split this circuit open here. If there is no jumper, we just scribble open one of those circuit board thingies here, okay? It's out of Las Vegas, okay? So it's a gamble. This is not the dungeon, okay? That's the room before the dungeon. The dungeon is back here. hang on, we got even a little bit of light in here.
Yeah, we have two dungeons.
Okay. And I got here a box with old power supply circuit boards. I don't take that out very often. Some smart trick. Okay, we got it.
Okay.
Okay. So we need a 471K varistor. See, this is, for example, from an old TV, and there are some on here. These blue thingies here are exactly what we need. Oh, I can't read that one.
You want me to read it?
And oh, look at that. This is...
It's defect.
Yeah, this is a power supply from halogen light bulbs in our house. And they are switching power supplies.
Oh, no. Now it's even more broken.
We need one part out of this.
How do you know it's not the broken part?
Look, it's exactly the same input circuit. There's your rectifier bridge as one integrated circuit. There's this little coil. Well, it kind of didn't survive the hit with a hammer. There's the input varistor. There's basically the circuitry for the output voltage. So all we got to do is check this piece here. Okay, listen, this is a 14N431K.
We need a D.
I would say this is good enough. I don't know what the difference is.
It's a D and you have an N.
Doesn't matter. That's probably like the shape of it. If your wife doesn't believe you, you go to ChatGPT. What's the difference between a 14D471K and a 14N471K varistor? The difference between the 1.4D4 and the other one lies in their series classification and possibly their construction or surge handling capacity. Let's break it down. D varistors are typically from the standard disc varistor series. N varistor could belong to a different series, sometimes with variations in surge rating, response time, or even lead spacing. Lead spacing is the width of how they spaced out here, okay? We can fumble that in. The 14 designation may indicate the disc size. So this is the diameter of this thing. So a 10 is 10 millimeter and a 14 is 14 millimeter. So I would say we can risk that, but and it's in the same circuit, okay? So it's doing the same thing.
It looks completely different to me.
No, it's doing the same thing, and it's Las Vegas, okay? It's a gamble. This is exactly how this is designed. So we use that like this, and then we can
zoom it.
And this is a AC472M. That doesn't sound as nice as the other one. The other one had more digits in common.
Yes.
Okay, so we'll use the other one. This one.
Can't you just order the correct one?
No, it's gonna be out of Las Vegas. I can also buy a complete new power supply if we blow it up. Also, I don't like it that they're smaller, okay? Because this unit is out of the US, and in the US there is one simple rule. Bigger is better. So
yes.
We're not gonna put something smaller into this power supply. A circuit board like this develops vibration because of the 60 hertz in the supply, and that's why they put silicone onto certain components so that they don't vibrate loose, okay, from handling. That's what's killing these circuit boards. Also, these capacitors, if they are exposed to very extreme heat in the desert from Nevada, they also die quicker, okay, because there is an electrolyte inside. It got electrolytes.
In idiocracy.
In idiocracy. So this is actually a well-designed circuit board. The other thing what I prefer on it, it got a clear coat on it to protect it from corrosion, and it has all the layers on one side. I hate simple circuit boards if the layers are on both sides. It makes them unnecessarily difficult to decode. But on one like this, you actually have a chance to repair it, okay? As an electrician, you only knows red and black and pluses minus.
But that's what I understand.
And that already took 10 years.
Yes.
And, we still need a power cord.
Oh, while we have the soldering iron out, we can fix my bike.
But I already fixed this like 4 years ago. It's broken again.
But it's 30 years old. I cannot not have it in my car.
If the circuit board is working and the soldering iron is still hot, I think.
And then we'll fix my bike.
Okay, we also need a power cord.
Christian built that door. That was like the first thing he built for that house.
We need a power cord.
That is not nice.
It's dirty. It's nice.
It's oh my God.
Okay, what about this one here? See, this one does not have a ground lock. but it's nice rubbery. Usually when I throw away electrical devices, I cut off the power cords because you can still use them, as you can see. And this one is probably in here for just about 25 years.
Yes, and I threw away my broken vacuum. And I got really in trouble for not
Because
cutting off the power
That one
cord.
had a really long power cord. Look how long this one is. How nice of a power cord that is.
So that's all of our remnants of the house building stuff. You know?
Oh, yeah, we got to get into that.
Yes, we never do. We always say,
Okay.
yes.
While we talk about house renovating, okay, in the last episode, Vera mentioned that the ceiling in this room is not high enough for a larger milling machine, okay? And then she said something about digging out this room, and we got a lot of comments, people asking, well, why don't you dig it out? We'll watch a video about this. Now, the room you're standing here, okay, this room, as well as this room, as well as our furnace room,
That was all earth.
was all earth, and it was higher up. And I dug out all those rooms with a shovel and a pickle by hand. And then I laid down a layer of concrete about 4 inches, so that's about 100 millimeters, and I put tile in here. I also plastered all these walls. Every wall you see here down in our basement has a thick layer of plaster on it, and those are granite walls, okay? They're not made from purchased stones. Back after the war, people didn't have any stones over here, but what they had was a lot of rubble, okay? And that rubble they used to make these walls. So look at the basement wall. This is made out of granite. This is 600 millimeters from here to here.
Yeah.
Okay. This is not your 2x4 US wall where you can simply run a cable. You need some serious equipment if you want to run an Ethernet cable in this house. Trust me. I got...
Like
Look at
here, that was a big debacle.
Okay, this here is my run an Ethernet cable drill, for example. This is what I need. But if I want to go up into our living room, I don't drill through it like this because the walls in the upper rooms are narrower, okay? And they sit on top of the very large 600 millimeter walls. If I would drill here, I would be like a foot off the side of the wall and in the middle of the room. So what I do is I drill here in an angle like this. And I aim exactly because I know how thick the layer of the floor is. I know how thick the wall is on top and where it's sitting. So I aim precisely and I hit and come exactly out of the corner. And then the other thing you need is this device, okay? This is not your little drill what you use in your 2x4 homes, okay? This is the equipment you need over here.
And that thing is like 40 years old.
It's 40 years old and it's definitely the best electric drill on the planet. It blows everything else out of the water. If I'm doing any kind of chiseling work in our house, going through those granite walls, this is like the baby one. I got then a big one, okay? A big
Yes.
electric power hammer. This is the basic equipment any family over here in Germany has if they do work in their old homes from 1930 to 1960, okay? When you get into the 1970 and 1980, then they already used pre-manufactured regular stones and you can use smaller stuff.
Yes. And whoever doesn't own one of those comes to us and borrows them.
Yeah.
On any given Saturday.
We are like a hardware store, except you don't have to pay anything.
Yes.
I'm able to plaster a wall like this with the angle irons and everything, and this is like this big of a layer of plaster, okay? So you need sacks and sacks and sacks of plaster, and you gotta mix this up and stuff. I laid down all those tiles, so I'm gonna cut in a couple of before and after pictures, how this looked before Vera and I moved in. There was no electricity in this basement, there was no heat, there were no doors. Remember we had these doors which you had like in a stable.
Yes, for
And
cows
then,
and...
remember when you came in here, there was all the sink and everything was exposed here and everything was rotten and there was an old sink here.
Yes, I remember.
And then the earth floor we had in here, remember
Yes,
that?
we dug that out.
Yeah,
The ground
we dug
was
out.
here and he dug out that. And remember, below here is granite. Not earth.
The
it's
entire
granite.
house is sitting on granite, okay?
Yeah.
So in certain rooms when I had to dig down, I needed some serious equipment to take that granite down another 3 or 4 inches to get a layer of concrete in here. This room, for example, where we keep our bikes and stuff, had like red brick walls, remember?
Yes, Robin had his wooden workbench here.
Da musst du den Huppel da noch so ein bisschen ausbalancieren, ne? And there was a layer of concrete in here, and that layer, when I chiseled it out, was like a centimeter, okay? Because there wasn't much material after the war. And the entire house didn't have copper wires. It basically had steel wires which were wrapped in cloth.
Yes.
That's all they had after the war. And then this room was the best one. This actually did have a stable door, like you would have in front of your pig stable or your pig, where you keep your pigs. This is the former outside wall of the house, okay? So this is also a 600 millimeter granite wall, and this was all granite rock. And people will say, now, why didn't you leave it like that? It looks real nice. Well, only if the granite rock is nicely broken into cubes, but this is not how that was made. This was all rubble, okay? It was granite rubble because it was cheaper. And then they puzzled it together, and it had like big, huge gaps, and it was impossible to fix this up.
And the mortar was already
falling out. So I saw no other way than basically plastering all this, okay? This is a heating pipe going through the house over the entire length, and then from there it branches up into the house onto the radiators. I left this because it was really high quality and really, really thick. But then everything from going here up is new. The entire house on top, I have every pipe, every cable, everything replaced. And then this workshop had like a sliding door here out of wood, and it was never really
and the window wasn't there, though. That was one big opening.
Yeah, it was one big opening. So we installed this window, we installed this garage door, we put down concrete onto the floor, and we basically plastered the entire room. And it goes on the outside of the house. Everything was kind of unfinished. So for us, there was a time before YouTube where we did house renovating for 5 years straight in a row without taking vacation. You guys see this now as it is since 2015, okay? And since then we haven't done a thing on the house, and now slowly our house needs some serious repair, okay? Because we're only doing YouTube, but this stuff is aging. A house like this needs a lot of maintenance.
Especially if it's used like ours.
Yeah, it's
heavily used.
Okay? We gave this workshop to Robin. This used to be my wood workshop, okay? And now he uses this for his forge. And you can see it's a really small ceiling height. This is how houses out of that era in Germany were built. I'm only 176, okay? If you're a tall guy, you can't work in here. Robin is my height, so he can actually forge in here.
But it's tough.
This is the second or third light fixture I already put in here.
Yeah, because when he hammers.
Okay, but because he is not very tall, just like me, this is perfectly suitable and it will work. But when he has his blacksmith friends over, they actually got to forge outside, because some of them are 6 foot something and they can't simply walk in here, okay? Then they go here outside and they got his forge here. And this is the back side of our house, which is, barely finished. But I plastered even this wall here. I never got to paint it. And I made this door, for example. This is a door, including glass, including 3-point latching, including frame, as well as this door here. You don't realize that, but I made this door, and the reason I made this myself at one point is because we didn't have any money. Okay, so I made this door to our dungeon back here. You guys been in here before. This is our dungeon where I keep my really rough supplies, and this is not heated in here, okay? So this is
it's cold.
YouTubers actually have also a real life. I decided to cut this nice cord here. So cut.
Oh my god. Yeah, usually when we do electrical stuff, we get the most desktop mechanic comments.
Those are desktop electricians then, okay? Yeah. And they know everything better, and it's easy to beat me with this, okay? This is gonna work.
So don't mess up the red is black and plus is minus part now.
Well, this is brown and blue, okay? Okay, we'll wire this back up here. There.
Yes, and what about the other one?
Well, I have to plug it in first.
Yeah, there's no room anymore. Oh, all the way over there.
Yeah, see, there. Get this wired up to here. Okay, we cut this off. Desoldering braid.
No suction tube.
Yeah, I got a desuction tube also somewhere, but this should work with. Out of the circuit board, there it is. Okay. And this one, we stick it in here now.
And the orientation does not matter?
Well, it's red is black and plus is minus, so tell me where it is. We're replacing the smaller one with the bigger one. So that cannot be wrong, okay? Bigger is better. That's the rule. When we first moved over there, I asked my colleague, well, what car should I buy? Guess what the answer was? Whatever you get the biggest engine you can afford. And over there, while we lived in the US, I stuck to that rule. Trust me, as soon as I made more money, I got myself a bigger engine.
Always used ones. And
Always
we
used ones.
fixed them ourselves.
See, I stuck this now in here. And we gotta cut this circuit. And here.
Okay. Oh my God.
Cut this off. You know how to cut a circuit?
No.
This pole of the big capacitor is connected to this one. So this is this intermediate link here. So what I'm gonna do is take a drill bit like this, and I just cut that out here with a drill bit. Just because you haven't seen me doing that, this is how this is professionally done. Conductor is gone.
And what
If it's not gone, we're gonna have 2 times 130 times the square root of 2. And that means then here, I draw the symbol for that. It basically means this.
Smoke.
And you can't get smoke back in on these circuit boards. Okay, let's put this back in here.
Oh my God.
This is all professionally done. It's either gonna blow right away or it's gonna work. Here you go over here. Arthur, if I blow it up, I'll buy a new one, okay? There's no light. I don't like that. Green. And green means it is charged.
I'm right now a little bit afraid of that thing.
Green. And they are full. They came charged out of the box, see? So we're gonna have to decharge it. Yeah, see, it's all indicated. They are full. But I wanna say, that's a good sign. We plug this in. And it's green, okay, so it's doing something.
God.
So I converted this baby right out of Las Vegas, okay, in our climate zone. So we add this into our video, and what else we gonna do in this video? And I'm gonna put this cord into our dungeon, and maybe when we move back to the US, we can use it again.
It might happen.
Depending on how the election went today, we can basically now go upstairs and listen to the results on TV. So thank you, Asa, for this great gift, and I hope you guys enjoyed how to rewire US circuits and make them plug into your wall outlet here in Germany. Now we're gonna go back to our engine topic.
Oh my God. It's a never-ending story.
I'm gonna have to look for my hot glue gun.
Okay.
Better fix Vera's little bicycle here. She has that on her mirror in her car. We gotta fix this back here. This is not 120 volt anymore and 60 hertz to 30 volt AC and 50 hertz. And we got this from Arthur, Las Vegas. Oh, look at that. Incredible. Look at this nice little bag. I see Vera carrying this around when she goes shopping. I wrote down who sent it to us and the date when we got it. These two are actually from our cars when we lived in the US, okay? I had a 350 Pontiac Firebird. It was an 87, and Vera had a 84 Pontiac Fiero. I paid $3,200 back then for my 350 Pontiac Firebird. Okay guys, we're gonna have to measure the head gasket thickness. That is done by measuring actually the piston protrusion in the cylinder head. And I have a special gauge which I made for that. And I also have an Excel spreadsheet where I can enter my data in and it automatically gives me back the correct grade gasket with the part number, and I can just go ahead and buy it. Get that adjusted to 0. The piston protrusion is measured in 5 millimeters in here in the horizontal in this axis. So 5 millimeter in here, 5 millimeter in here. This would indicate 0 if everything is flat. Now before I start measuring, I gotta give the crankshaft 1 or 2 revolutions so the piston goes into its natural position because it has play on the skirt and everything. Now I put the indicator on here, get it nicely horizontal, and now I look for the highest spot. There it was. This is the highest spot. It's 0.635. Now I go in this position to the other side and measure the highest spot without moving the piston. That's important. That's why I got this light fixture here. And this is 0.65. Now I enter this into my spreadsheet here, 0.635. Second piston, 0.67, 0.68. Now I got this bank measured and I just measure it again to have a better average value. Now I got all my measurements entered into my table. What's really important is that the largest deviation in one bank is less than 0.1 millimeter. And you can see that here, it's definitely less. I got 0.058. If this deviation in one bank would be too large, that would indicate either like a crooked crankshaft or a connecting rod in the wrong length or something like that. So now with all my dimensions in here, my table automatically selects me the correct grade head gasket and it indicates the L-ring part number here. Now note that this is different from the 3-liter to the 2.7-liter, which is this table up here. So I got both tables here. This is what the head gaskets look like. They have here these little tabs. So this is a grade 2, this is a grade 3, and this is a grade 4 here. You can see that. Bank 1 gets a grade 4 right here. Bank 2 gets a grade 3 right here. One more measurement we have to get out of the way before we start the assembly is the big end side clearance. That's basically this play here on each connecting rod. That needs to be within 0.1 to 0.41 millimeters. So I'm gonna check this and record it in my Excel table in case this engine fails, so Vera knows what I screwed up. Yeah, 0.25 is nice and loose and 0.3 is tight. So I do that on all of them. So I got the side clearance values entered in here and they're all green and in tolerance. Now in the last episode, people asked me why didn't I weigh the con rods and the pistons. And the reason is that I used new pistons from Neural and they were all the same weight. I did verify that. And I also used OEM con rods and they had all the same weight. And I was not able to retrieve any information from Ford about the values I'm supposed to have. So even if I would have a deviation in between the parts, I wouldn't know what to correct it to.
So that means I have to get undressed again.
Yes. And I'm using your new Milwaukee tool from Arthur from Las Vegas. Okay. And we gotta lift it up first.
Wait a second.
Keep on going. Okay.
Oh, that was heavy.
Yeah. Okay, so this completes our little bit of a different video this week. I hope you still enjoyed it. We're already on to the next project here and we're test driving Vera's Discovery 3 now. So we want to thank our patrons a lot for their support and
we'll see you next Sunday.
Most likely with an outdoor wrenching video on our lift.
Yes, because we're test driving my Discovery now.
Yeah, right now.
Major debacle.
Right now it's driving.